A network system is a mathematical structure made up of nodes and edges. A node is a person and their device, and an edge is a bridge between a node. I'm going to discuss them along with a term called betweenness as I basically take you on this journey to compare network 2 and network 3. Two networks that are completely different but have the same nodes, if you will. And I'm going to show the fragility or the robustness of the networks depending on their structure. So my name is Ashley Gooch, and let's get started. So here you have network 2 and network 3 just side by comparison. Just by looking at them, automatically you may want to assume that network 2 is going to be the worst network in that regard because of all of the twists and turns and edges that this has. But what if I tell you that's not necessarily the case? After doing a little bit of experimenting, I actually found that network 2 is the better of the two networks, and I'll explain why in just a bit. But because of that, I actually believe that network 2 would survive malware attacks or if nodes are destroyed or go down for any particular reason because of its structure currently. So as you can see right here, the red indicates a high betweenness. And I mentioned betweenness earlier, but all that really means is it's a term to describe the degree of the edge between the two nodes. So essentially, a high betweenness is essentially a bottleneck, meaning if that node goes down, then it's actually pretty bad for the network. And so what this is saying is that if these three nodes go down, it should potentially be worse for this network. But we'll see why that's not necessarily the case in just a minute. Now, as you can see with network 3, the same exact rules apply, where the high betweenness means that if this goes down, then the nodes connected to them are actually in big trouble. And if you notice, the betweenness of network 3 is actually quite high by comparison to network 2. So what I did is I actually removed those nodes that you just saw in those last slides, and now it looks completely different. So network 2 actually looks still okay. There's some twists and turns that might not be there, like this is a little broken and a couple here, but altogether the network still looks okay. Whereas with network 3, giant bottleneck. So network 3 absolutely is completely fragile just by that straight linear path that it was having before. Whereas network 2 does pretty well to survive that. So my recommendation for anyone who wants to use the network system is to not make it so streamlined like network 3. It may look pretty, but in the end, it's absolutely not feasible or worth working with. As you can see, giant bottleneck, communications completely cut off just because I removed two nodes. Whereas network 2, still pretty good. All right, so thank you for coming along with me with this analysis. Once again, my name is Ashley Gooch, and I hope you have a great day.